I spent over $100,000 on computer parts, and we're going to see how much money we can make renting RTX 5090s to people online. What we've got here is all the components that we're going to use to basically build a fully functioning, full PCIe Gen 5 server that can support 8 5090s in 7 rack units. So this is the system that we're going to put around the 8 5090s. The most critical design choice here is having a motherboard that'll support all cards at the full bandwidth PCIe Gen 5. In order to do that, you need a fairly specialty motherboard that's going to have enough MCIO connectivity to enable to use something like a riser like this. So because obviously you wouldn't be able to put 8 5090s on a single motherboard, you need to fan that connectivity out throughout the chassis to little cards like this so that you can have enough spacing to ensure that everything is just where it should be. Next component is the processors. So because these are considered last gen now, we're able to get a very high-end Genoa processor for fairly cheap. I think we paid about $2,000 each for these EPIC 9654 processors, which I think they were released in 2021, and they would have been like over $10,000 a piece. You can unlock a ton of value just by sort of looking at the high end of the last generation, and it depreciates the most, so you can get a really, really good value if you're building your own server this way. The next component is the memory, and honestly, I don't know if we would have gone with as much memory as we are, but the critical factor here is that every one of these processors has 12 memory channels. So in order to get the maximum memory bandwidth from the CPU to the memory, and then ultimately the reason that you do this is that memory is going to flow into the GPUs, you want to have at least 12 DIMMs per processor. So that forced us into 24 DIMMs total on the motherboard here. And because DDR5 doesn't really come in 16 gig DIMMs, we ended up with 768 gigs total. For network connectivity, there's 1 gig onboard, just RJ45 ports on the motherboard, and then an IPMI. But to interconnect everything at high bandwidth, it made sense to go with 100 gig NICs. So this is an old ConnectX-5 card that we just got on eBay. I think it was like $150 to $200. And this uses a full PCIe Gen 4 X16 slot, which is actually, it's quite good because having a lot of bandwidth between all of the nodes means that we can scale the number of GPUs that can work together a lot more efficiently. The final component is the storage. So these are 3.84 terabyte Intel PCIe Gen 4 NVMEs, and they're not that much cheaper than you would get brand new. And honestly, a lot of the time you probably want to go with brand new storage, but I think we paid $250 to $300 per 3.84 terabyte drive, and they're very, very performant, lots of capacity, and we can put up to 4 of them onto this motherboard with the remaining PCIe connectivity that we have. So the biggest challenge with 5090s is the form factor, and because of that, we needed a custom server that would be able to support 8 of them in a single box. So this is the chassis that we ended up going with. It's obviously quite large, but in order to support 8 5090s, we need to actually separate the GPUs so that 4 of them are at the front of the chassis, and then the other 4 are at the back of the chassis. One of the benefits of using a chassis like this, obviously, is you can get a lot of airflow going right over the cards because it's all cased in, right? So air comes in the back and has to go out the front. The other great feature of a chassis like this is you can use an actual data center power supply. So in the chassis here, and we'll cut to a clip of it, is a power distribution board, sometimes referred to as a PDB. And what it can do is actually support 5 separate CRPS power supplies all connected to it at the same time. And that lets us do cool things like if one breaks, we can swap it out while the system is on, or just to handle the sheer amount of power required by all these cards, we can have 5 1600 watt power supplies all working together, right? And coming right off the PDB, we actually have the PCIe Gen 5 connectors that are going to go right into the cards themselves. So really excited about this. We're going to get into building it now, and we'll see how it goes. we got to put the motherboard in and connect it to the power. But in order to do that, we're going to have to take off the plate here that holds all the GPU risers. So I'm going to start doing that now. So this is the chassis with the motherboard. We've installed all the MCIO cables. So each of these are what power all of the risers, or not power, but they carry data from the risers back to the motherboard. What we've got to do next is we're going to install this drive bay, and this is actually what holds the network cards as well. You can see the drive bays on the front here. There's 4 drive bays for the NVMEs, and each of them basically takes half of an MCIO cable. So we're going to wire up 2 cables to both drive bays, and then we'll put our 100 gig NIC on one of these spots here. I've got to throw a riser in there as well. All right, so we finished building the system. We've got the motherboard with the CPUs and the memory installed down below, and then you can see all of our cabling here. So this is just the raw MCIO cables up to the risers here. I think there's a good chance that this works on like the first go, but you never know, right? Like, there's so many little connections in here that if even one cable is kind of loose, it's just gonna break, right? But that's the beauty of trying. The chassis is ready to go. GPUs are out. We just got to unbox this last one, and then we're gonna install them all and fire this bad boy up. So we just took the machine up here. As you can tell, it's extremely loud because of the fans blowing across the GPUs here. We were able to basically confirm that all of the components are showing up in the BIOS. We've set the BIOS to basically give the full X16 lanes to each GPU, and then we set up the NVMe drives as well as our NIC over here. What we're going to do next is we're going to start a burn test on these GPUs to make sure that we've got, we can see the full memory bandwidth actually transferring into the GPU memory, and then we'll start a stress test on them and just make sure that their thermals are holding strong, with the airflow coming over them. So I'll fire that up now, and then we'll switch the views. All right, so this is a PCIe stress test that we use to test the machines, and we've got the motherboard actually in the tool here. And it's going to tell us everything about all the different links to all the different GPUs. So here we're going to launch this bandwidth test, and basically what it's going to do is fill the memory of each GPU and tell us basically how quickly it worked for each one. So this is usually like a good first test to see, if there's any issues, you're not going to get the full bandwidth of every GPU, but you can see here, every GPU is essentially receiving data at almost 54 gigabytes per second, and then we're actually able to transfer data out of the GPU back to the host at the same speeds, essentially. So if there are any issues, you'd see like a disturbingly low value in there. So we know that the links are all good. the next test we want to do is, might take a second to load, but the NVIDIA just driver will output basically the thermals of all the cards. So what we want to do is put all the cards under a super heavy load and see if they're actually going to get really hot, or if one of their temperatures runs away on us, then we know there's a problem. So you can see the test is actually, it's filling the VRAM of the cards here. So once it's actually loaded the test into all of the cards, you'll see the power kick way up here as it starts to work the GPU really hard. Okay, so you can see there's the memory of the GPUs is pretty much full across all the cards, and the test has started. So this is stressing the cards out. It's pulling over 500 watts on every 5090 here. And what we want to do is, over the course of a couple hours, watch and see if the temperature of these cards shoots way up, or if we see a fan at 100% and then the card has to thermal throttle or something like that. We want to watch for all of those things. So we're going to let this bake for a little while, and we'll come back and see how it's holding up in a bit. Okay, so it's been like maybe 20, 30 minutes so far, and you can see here the cards are still under full load. Their temperature shot up, so they hover between around 60 and 70 degrees Celsius typically. And you can see that the fans on the cards are hardly going, right? So if it ever got hotter, or maybe you're in like a hotter environment, the fans on the GPUs themselves would kick up, and that would actually get more cooling over the heat sinks. But you can see here it's holding pretty strong, so I think we'll consider that a success and do some more in the later videos. So we built the server. It works. We've got all the 5090s showing up in it. I think like the bigger plan and what we're hoping to make some more content about is we have enough parts here to do 5 of those. So we're going to put together 5 5090 servers. We're going to wire them all up at 100 gig. And then I want to start using that cluster for, different AI workloads. We want to rent it to people online, maybe mine some crypto with it, and just make a bunch of content about what can you do with GPUs in 2025. So that is the plan. If you enjoyed the video and want to know more about the server, you can reach out to us or just follow along, and we'll probably do more in-depth content about it. And yeah, just feel free to engage. Bye.